In this section, we're going to take a look to controlling BGP routing updates. If there is more than one route between your network and the ISP, you may need to filter certain information during the exchange of BGP updates to affect route selection or to implement a management policy. You can filter the BGP updates via prefix lists, ASPath, and the route map. And let's take a look to the prefix list filtering first. In here, we have router BGP and autonomous system number, and we have the neighbor statement, which is pairing with this guy, and we are using prefix lists any 8 to 24 NAT while we are pairing. Okay, and we are using this prefix list inbound. So we defined an IP prefix list with this name, which is permitting all routes which are greater than or equal to 8 and less than or equal to 24. Okay, what this prefix list saying me that the prefix list named any 8 to 24 NAT is configured to match routes from any networks that have a mask length from 8 to 24 bits. The 0000/0 network and length combination does not match a specific network, rather it defines any network, as you know. The parameters greater than or equal to 8 and LE24 specify that any network with the mask length between 8 and 24 matches the prefix list entry. And here is the ASPath access list filtering. Autonomous system, this guy, 65,000, does not want to act as a transit autonomous system between its service providers, let's say that, and this situation is avoided by ensuring that only locally sourced routes are sent to the ISP. And then the customer avoids receiving IP packets from the ISPs for destinations outside its own autonomous systems. Alright, what's going on in this scenario is we have gateway 1 and gateway 2. We are defining an IP ASPath access list 1 that permits something like that. That means locally originated routes. Then, under the BGP statement, when we are neighboring with ISP2 and ISP1, we are using this ASPath access list as a filter list to outbound. Alright, the ASPath access list in here permits only the empty string matched by the regular expiration and this guy, which represents, as I told you, locally sourced routes. By applying this filter list on outgoing information to all neighbors, the customer announces only its local routes. And here is the route map filtering, how we can configure a route map filtering. In route map filtering, what we are doing is just defining some ISP1 out and ISP2 out, two separate IP prefix lists first. This ISP1 out is permitting this statement this IP address, and ISP2 out is permitting this IPN prefix. Then I'm defining a route map which has a name of ISP1 out, and I'm matching the IP address that I'm using in here and in here. Okay, then under the BGP statement, when I'm peering with this IP address, I'm using this route map. Okay, this is gonna be ISP1 out route map, and this is gonna be ISP2 out route map. Okay, what ISP1 out route map is saying me that just hit the IP address in this prefix, and ISP2 out is saying me that just hit the IP prefix list in this. So I have this route and this route in router 1, as you can see. So I'm announcing this prefix just to ISP1, and I'm announcing this prefix just to ISP2. And lastly, we are going to talk about the BGP Peer Group. When you configure BGP on a router, it's possible that some of the BGP neighbors share the exact same configuration. This can be annoying since you have to type in the exact same commands for each of these neighbors. Also, when BGP prepares updates, it does this separately for each neighbor. This means that it has to use CPU resources to prepare the update for each neighbor. To simplify the configuration of BGP and to reduce the number of updates BGP has to create, we can use peer groups. Let's take a look to the figure now. We have Jansi, Jazz, Owen, and Jules routers, and we are peering with these routers each other. Okay. Here's the configuration of Jazz, router BGP 123, and neighbor with Jansi. Same configuration in here and same configuration in here. But when we take a look from the perspective of Jansi, what I need to define is neighbor with Jazz, and for Jazz, define an remote autonomous system, define a route reflector client command, which we are going to talk about later, and define a remote AS as I told. Okay. And for Owen, that's the same thing. For example, neighbor Owen's IP address will have a remote AS of 123, and neighbor Owen is a route reflector client. And for Jazz, I'm gonna type the same thing. For Jules, I'm gonna type the same thing again. For simplicity, what I'm doing is I'm defining these three separate guys as a peer group. So I'm implementing these commands to the peer group instead of typing separately for each neighbor. Neighbor peers is a peer group. That's the name of the peer group, peers. And neighbor peers are in the remote AS123, and they are my route reflector client. Okay. And after defining this peer group, the only thing I'm doing is attaching the neighbors to the peer group by typing neighbor IP address and peer group name.